So you want to add AI to your app, a chatbot, a summarizer, a smart search. It sounds simple: call a model, get a response. But then the questions pile up. Which model? How do I run it? Is my data safe? What does it cost? It can feel like you need to understand everything before you can build anything, but you really don't. In this deep dive, we'll make AI on AWS make sense, with pictures, all centered on one service. Amazon Bedrock, foundation models, one API to many models, prompting RAG, embeddings, agents, guardrails, and cost. By the end, you'll know exactly how to build real AI features on AWS. Let's start with the engine, the foundation model. A foundation model is one huge AI model trained on a massive, broad slice of the internet. So instead of being built for a single task, it can do many: write, summarize, answer questions, translate, generate images, even write code. A large language model, an LLM, is just a foundation model that specializes in text. Under the hood, it works on tokens, small chunks of words, reading your input as tokens and generating its answer one token at a time. The key shift to internalize: you don't train these giant models yourself. You rent them, ready-made. And on AWS, the place you rent them is Bedrock. Amazon Bedrock is the heart of this whole video. In one line, it's a fully managed, serverless service that gives your application access to many top foundation models through one single API. No GPS to rent, no servers to run. You just call Bedrock from your code, send a prompt, and get a response. And here's the magic. Behind that one API sits a whole catalog of models from different companies: Anthropic's Claude, Meta's Llama, Amazon's own Nova and Titan, plus Mistral, Cohere, and more. Want to try a different model? Change one line. That's the superpower: one doorway, many models, swap anytime. Now, how do you actually talk to a model? You send a prompt, and you shape the answer with a few controls. First, a system prompt. This sets the model's role, like you are a helpful coding assistant who explains things simply. Then your actual user message. And a couple of inference settings: temperature, which controls creativity, keep it near 0 for factual, predictable answers, turn it up for creative ones, and max tokens, which caps how long the reply can be. Remember, the model is stateless. It doesn't remember past messages unless you send the conversation history each time. Send a prompt, get a response. That single round trip is called inference. Before we go further, the question everyone asks: is my data safe? On Bedrock, yes, and this matters. Your prompts and your data are never used to train the underlying foundation models, and they're never shared with the model providers. Everything is encrypted, in transit, and at rest. If you customize a model with your own data, AWS makes a private copy just for you. Your data stays yours. This is exactly why companies are comfortable building on Bedrock. You get the power of these huge models without handing your private information over to anyone. Private by default is the foundation everything else sits on. Here's the most useful trick in the whole toolkit: RAG, Retrieval Augmented Generation. A model only knows what it learned in training. It doesn't know your company's documents, your policies, your latest data. Ask it about those, and it'll confidently make something up. RAG fixes that. Before the model answers, you search your own documents for the relevant pieces and hand them to the model as context, so the answer is grounded in your real data, with sources. On AWS, Bedrock Knowledge Bases does this for you automatically, pointed at your files, and it handles the rest. Retrieve, Augment, Generate. That's RAG, Retrieval Augmented Generation. So how does RAG find the right document? Through embeddings and vector search. An embedding turns a piece of text into a list of numbers, a vector, that captures its meaning. The neat part: texts with similar meaning end up close together in that number space, even if they share no words. Pushing code to production lands near deployment. So you convert all your documents into vectors and store them in a vector database. When a question comes in, you turn it into a vector too, and grab the nearest matches by meaning. That's semantic search, finding by meaning, not keywords, and it's the engine that makes RAG actually work. Next, the idea that turns a chatbot into a doer: agents. A normal model just talks, text in, text out. An agent can take action. You give it tools, functions it can call, like look up an order, hit an API, or run some code, and the model decides, on its own, when it needs a tool to answer you. It reasons through the task in steps: think, call a tool, read the result, continue until it's done. On AWS, you build these with Bedrock Agents and Agent Core, the production layer for running agents. A support bot that checks your real order status: that's an agent using a tool. This is where AI starts actually doing the work. Now the safety layer you must not skip: guardrails. The moment your AI app is public, assume people will try to misuse it, and you can't fully trust the model's output either. Bedrock guardrails sit between the user and the model, filtering both sides. They block harmful content, detect and redact personal information like names and card numbers, let you forbid whole topics, say a banking bot that must never give investment advice, and they include grounding checks that catch a large share of hallucinations. You configure a guardrail once and apply it across any model, before and after every call. It doesn't make the model smarter, it makes your app as personal information like names and card numbers. So when do you use what? 3 levers in order. Start with prompt engineering, just write better instructions and give examples. It's free and instant, and it gets you surprisingly far. If the model needs to know your private, ever-changing data, add RAG, that gives it knowledge with citations, and you just update the documents. Only reach for fine-tuning, actually retraining the model's weights when you need a very specific style, tone, or behavior. The base model can't reach, it's the slowest and priciest. The rule of thumb, RAG changes what the model can do as, fine-tuning changes how it behaves. Start simple, escalate only when you must. Bedrock isn't the whole AI story on AWS, so let's place it. Think of it as 2 doors plus a toolbox. Bedrock is the buys door, use ready-made foundation models through an API. Amazon SageMaker is the build door, for teams who want to train and host their own models from scratch with full control. And then there are the pre-built AI services for specific jobs. You don't need a foundation model for Rekognition for images, Transcribe for speech to text, Poly for text to speech, Translate for languages, Comprehend for text analysis, and Textract for reading documents. Match the tool to the task, ready service, Bedrock, or SageMaker. Let's talk money, because it's refreshingly simple. Bedrock charges you per token, both the tokens you send in and the tokens the model generates out, and the rate depends on which model you pick. Smaller, faster models like Amazon Nova or Claude Haiku cost a fraction of the big flagship models, so a smart habit is to start cheap and only move up if the quality really needs it. By default, it's on demand. You pay per request and pay nothing when idle, perfect for spiky traffic. If you run huge, steady volume, you can pre-buy dedicated throughput. Watch your token usage, especially long RAG contexts, and your bill stays small. Let's make it real with PhotoApp. Imagine we add AI features. A support chatbot answers questions about a user's account, and with a knowledge base over our help docs, RAG means it answers from our real policies, not guesses. When a user uploads a photo, a Bedrock call auto-generates a caption and tags that's a foundation model doing vision. A search box lets people find photos by meaning, sunset on a beach, powered by embeddings and vector search. Guardrails keep every response safe and private. One app, several AI features, all through Bedrock's single API, no AI infrastructure to run. Here's the whole thing in one picture. A user talks to your app. The app calls Amazon Bedrock, one API, and picks a foundation model. For questions about your own data, Bedrock knowledge bases retrieve the right passages from a vector store and feed them in. That's RAG. For actions, an agent calls your tools and APIs. Every request passes through guardrails for safety, and your data stays private the whole way. Notice the shape, your app on one side, one Bedrock door in the middle, and behind it many models, your knowledge, your tools, and your safety rules. That's a real production generative AI architecture on AWS. Let's bring it together. A foundation model is one giant general purpose AI, and Amazon Bedrock gives you many of them through one managed, serverless API privately. You shape answers with prompts and inference settings. You give the model your own knowledge with RAG, powered by embeddings and vector search. You let it take actions with agents, and you keep it safe with guardrails. Choose prompting first, then RAG, then fine-tuning only when needed. Bedrock to buy models, SageMaker to build them, and ready. AI services for specific tasks. Pay per token, start small. That's generative AI on AWS, clear and buildable. And that's AI on AWS, demystified. Not a wall of jargon, just one clear path, foundation models you rent through Amazon Bedrock, grounded on your data with RAG, made useful with agents, and kept safe with guardrails. You really don't need to understand everything to start. Pick a model, send a prompt, and build from there. If this finally made generative AI on AWS click, do me a favor and subscribe to VN Cloud. The whole point of this channel is taking the scary parts of AWS and making them simple, with pictures. Tell me what to break down next, and I'll see you in the next one.